Part C.2, Graphs of Asymptotic Notations. In this video, we want to understand our asymptotic notations visually. Yeah. So we want to, from the graphs, what those asymptotic notations really mean. Yeah. All right, so let's look at the first asymptotic notation, graph of big O notation. Big O, we just learned that, the big O, right? Using multiple of G function to approximate from upper bound on the given f of n function. From the graph, you can see like this. Yeah. This one is the f of n function. Yeah. Then we have a g function. Yeah. After we have that g function, now we want to use certain multiple, c multiple, certain constant, positive constant c multiple of g function to approximate from above. Yeah. So the graph of CG function should be higher. We know the value should be larger, higher than that of f function. But there is one special line. After passing n0 line, n equals n0 line. So this line, we know that is n0 line. After passing this line, right? After passing that line, the right-hand side of it, so that is n greater than n0. Left-hand side, so this part doesn't matter. So doesn't matter the left-hand side part of that vertical line, the dotted vertical or dashed vertical line. It doesn't matter. That's the meaning of sufficiently large. Yeah. So you can move that vertical line to the left, to its right. Yeah. But as soon as you choose certain place, you should fix it. You should fix it. Okay? Yeah. Because this n0 is not a variable. n0 is not a variable. It is a special constant. Yeah. N is a variable. Yeah. All right. All right. The second one, big omega notation. Yeah. Here, that is our fifth asymptotic notation. So look at what are those asymptotic notations we have learned so far. Yeah. The first one, little o notation, right? Little o notation, the first one. The second one, big theta notation. The third one, little omega notation. All right. The fourth one, yeah, big O notation. Then the fifth one, the one we're going to learn, big omega notation. Yeah. So that's all we need for this class. Yeah. Total five. All right, so look at the definition of big omega notation. For a given function g of n, the notation big omega of g of n represents the set of functions f of n that satisfy the following condition. So what are the conditions? There exists some positive constant c and some non-negative integer n0 such that, so this part looks the same as the part we described big O notation, right? So we use the same part, but the condition is different. The condition is f of n greater or equal to c multiple of g of n. Here you can see we approximate f of n from the lower bound, from the bottom, not top, the bottom. For all n greater or equal to n0, sufficiently large. All right? So the only difference, we change the direction of inequality. Switch from upper bound to lower bound. That's the only difference. All right? All right. Next, the graph of big omega notation. That is the graph. Here you can see c multiple of g of n is used as approximate function from lower side of f of n function. So we have that sufficiently large condition for n0. Okay? I mean for the problem size n, but this n0 is used to describe the meaning of sufficiently large. All right, so that is the big omega notation. Big theta, big theta we learned, but here we want to use graphs to understand big theta notation. So what's that? All right. Specifically, big theta notation, definition for a given function g of n, still, so the top part the same as before. The notation big theta of g of n represents the set of functions f of n that satisfy the following condition. But in the condition when we describe, we need C1, C2. Two positive constant. There exists some positive constant C1 and C2 and some non-negative integer n0 such that now the inequality this time C2 g of n less than or equal to f of n less than or equal to C1 g of n. All right. So in this inequality, we only consider when n sufficiently large. So we use n0 to describe the meaning of sufficiently large. All right? All right. So then, graphically, this time we use both upper bound and the lower bound. All right, C1 times g of n as the upper bound approximation of f of n. C2 multiple of g of n as the lower bound of f of n. Okay, so here you can see, in this way, we can describe these as these three. In this part C.2, we just look at three asymptotic notations. So these three, big O first, then big omega second, and big theta the third one. All right, so that's our video C.2. Then C.3, the last one of part C, I want to give you many computation examples. We want to use limits to compare two growth functions. But here I want to, practice or show you how to calculate the limits. Yeah. So we will use that L'Hopital's rule a lot. L'Hopital's rule, derivatives, calculus, some basic techniques in calculus. All right, so that's the part C. It will be pretty long, part C. Yeah. All right, so let us finish part C.2 first. All right.